Okay. So here, oh, that was taped. Yikes. Okay, here we go. So example 1 in day 4. We're gonna just start. Hey, Seb. All right. We gotta do it every day, don't we? I hope he's watching, and I'll be mad if we do all these shoutouts and he's not even listening. You better have gotten a internet cafe, you. Okay. So he said, I don't know. I'll be in a small French village. Oh, life. N equals 1 to infinity, right? N over, is that the example? Did I do it right? Yeah. Okay. So what is your intuition here? Very good. Right? Intuition says convergence. Why? Why, Colin?
It grows so much faster on the bottom.
Yeah.
Softball questions in college.
Fireball or Smarty? Smarty for Smarty. Smart.
What are you
I know, right? I know. They went out of fashion for because I think they're such bad candy.
Are you on some sort of drug?
They're so gross.
Yeah, I know.
Warheads are delicious.
Okay.
Fireball is so good.
Drug of life, Noah. So intuition is convergence, and Colin said it so lovely. He said that if you look at this as you know, 2 pieces, right? This is just a linear function. This is exponential. And the whole idea, you know, there's like a classic story of a philosopher in the Arab world who wanted to be paid with a grain of rice on a chessboard. You know this one? And the king was like, oh, no problem. And then it doubles every chess peg you go over. You know this? Mm-hmm. And the king's like, oh, yeah, I'll pay you. And then,
What do you mean?
What a dummy.
so like he had an 8x8 board. I'm not gonna drop it, you know. And he's like, just put 1 grain of rice in the first square. The next day, to pay me to help you. The next square put 2 grains of rice. The next put 4. So it was an exponential equation. The next put 8. And he ended up having all the rice that was grown in the entire region for the whole season. And the king was mad and had him executed, so it was a bad decision. So, but clearly that grows bigger than 1, 2, 3, 4, right? So this must converge. And I love that everyone was like, converged up. Yeah.
Is there any
Wait, sorry, what?
if you put n to any power, does it ever go faster than
N to any power, like any polynomial will always grow smaller than an exponential, always, yeah. Polynomial always grows smaller. Okay, so now let's try and prove it. How are we gonna prove it? Prove it. What do you guys want? You guys have lots of tools now, right? What's the one you should always do first? I know I've said this a lot. Divergence test. But we're trying to show convergence. That doesn't really work. Let's just do it because I want to show you as many times as possible. Oh, dear. Oh, you can use L'Hopital, can't you? Because you guys know so much. Right? You get infinity over infinity in undetermined, in indeterminate form. So then we can do, what's the, I'm just doing this to remind you guys what the derivative of 2 to the n power is. Ooh! Who said that? Was it Noah? I know it wasn't Amir. Good. I'm trying to listen to him because Alan says I'm ignoring Noah.
You are.
I know, so I'm trying to pay attention more. I know, so I'm trying. So now we get, what do we get? 0. Inconclusive. But, you know, right away, our intuition was convergent, so all we did was show that our intuition may be right. Right? Okay, woohoo! Okay, I know, my boy. All right, so 0, 1 over 2 to the n. So failure. What else should we try? Comparison test.
I would not know that if I saw that on the test.
So the comparison test. You guys just took a little quiz on this. What do we have to do? We have to find what?
Behaves the same way.
Yeah, so we need to find, very good, come on, we can use candy. I got lots of candy today. Come on. Oh, I see. Fire! Woo! Good catch. That's a terrible throw. So find some B sub n series that's convergent, that is larger than Because we need to show that this is going to be tinier than one that we know converges, right? That sneaks under it. But here's the hitch. We know p series. That's not a p series. That's n to the p power. That looks like a geometric, right? 1 over 2 to the n. That's geometric, but that's not this. This has a variable in the numerator. As a matter of fact, n over will always be bigger in our domain than that, won't it? So a sub n is actually larger than a known convergent series. No good. That fails too. That doesn't work. So that one, oh, we're going through them, aren't we? What else? Integral test?
Let's do the limit comparison
All
test.
right. Integral test. Yep. All right, let's do limit comparison test. I mean, this is really a review. You guys know we're just doing this as a review, but I think it's good for you to see this as much as possible. So limit comparison test, let rho equal, oh, that's a terrible row. It's okay. So we need to look at general term. So what are we going to compare it to? A known convergent series. All we've got are geometric. That's our only choice. 1 over 2 to the n. So now what happens here, that's the limit as n goes to infinity of this term over 1 over 2 to the n. Bump, bump, bump.
Oh, man.
I know, it's really, the calculus is not working out for us right now. It's really, really being uncooperative. Time for a new test. And it's my favorite one. It's my favorite one. I love this test. You guys will love it too, I'm sure. So fail. You know, if we get 0 infinity, we don't, no good.
Oh.
So now the ratio test. Now the ratio test is written in your notes. You see I have it all typed out there for you, right? Here's the concept. If you guys want to see the proof is on page 553. It's not that great. I'm just going to explain the idea. Okay, so, Xander, do you mind closing the door? Thank you. So I'm just going to show you the basic idea. So the ratio test. Obviously, we're going to take a ratio like the limit comparison test, but we're going to compare the series to itself. And you know, think about a geometric series, right? So we have. So this is, let's say, a geometric series. We have r to the n, right? What is that r? So how do we get that r in a geometric series? Yeah, it's a ratio of what?
The 2 terms.
Yeah, 2 consecutive terms, right? So we take a term and divide it by a previous term. And what happens if that's the absolute value that's less than 1? It converges. So here's the funny thing. We're actually going to kind of treat this like a geometric series. We're going to find the ratio. We're going to take a term, divide it by a previous term, and see, is that absolute value? Well, these are all positive, so is that less than 1? If it's greater than 1, it's going to diverge. If it's less than 1, it's going to converge. If it's 1, this test is too... It's going to be inconclusive because we're taking the limit as n goes to infinity. Too close to call. Right. It's too close to call because it's infinity. You'll see it on your classwork. Classwork goes through this. If it's greater than 1, it diverges. If this is less than 1, it converges. If it's 1, you can't say anything. So now I'm just going to do some examples. I told you I was going to go fast today. What's my time? Ooh, I got 45 seconds for 2 examples. Okay. I'm such a talker.
All
I've
right,
always
take
been a
an extra
talker.
2 minutes.
All right, let's do this example. So we're going to let rho, this time we're going to let rho equal the limit as n goes to infinity of 1 term of this series divided by a previous term. Okay? So now what you're going to do is you're going to plug in n plus 1 every place you see an n up here. So we're going to do equals the limit as n goes to infinity of So I take out the n, I put in n plus 1. Divided by, I take out the n and the exponent, put in 2n plus 1 over the previous term. You guys with me?
Yes.
So we're really doing, thank you for the voice of confidence. We're doing a ratio test on a non-geometric series because we're taking the limit. And I don't like this. When we divide by a fraction, it's the same as multiplying by the reciprocal. And can I just do that?
Yeah.
I'm just going to do it. So I'm going to multiply, and on my answer keys, I did that every time. So I'm going to multiply by the reciprocal of that. Okay. Yep, that's what I thank you. Thank you, that's what I meant. Smarty. Thank you for paying such close attention. That's exactly what I meant. So now, it's all about algebra rules and simplifying. So here we go. So it's the limit as n goes to infinity of n plus 1 over, how can I rewrite this? Go.
2 to the n times 2.
Yeah. 2 to the n times 2. Booyah. Booyah, it's good. It's good. To the n over n. And this is the fabulous thing, because you see what's going to cancel? That pesky 2 to the n. It cancels. We don't like that 2 to the n. It's very hard to deal with in these things. So, bye-bye. Bye-bye. There's that Saturday Night Live skit. Bye-bye. Limit as n goes, you guys have that. N plus 1. What? Okay. So now, what does that equal? 1/2. Now that doesn't really tell us the sum. It doesn't tell us. All it tells us, that is an indicator. This is not a true ratio. It just tells us because, and please, you guys can, finish your proof. Thus, since rho equals 1/2, this converges, and you're done by the ratio test. Finished. Okay. So that's it's kind of cool. Now I just need to show you one more quick example, and then I'm going to let you guys work on your own. And I know I'm going over a little bit, but I'm almost done.
If it's like -1, it converges to.
So the terms have to be positive. All these terms, these are all these tests are only with positive terms. So you're only going to get a positive ratio. Good question. Thank you. Erase?
Go for it.
All right. I heard an okay. I'm going. So let me do one more example, just because this test is great with 2 to the n, and if you have n factorials, you haven't done this for a while. N factorials, I know, right? I know, n factorials. So here's an example 2, and then I'm done. What about this? 3 to the n over n factorial as n goes from 1 to infinity. Intuition's harder here, right? Because if you have like 6 factorial, 6 times 5 times 4 times 3 times 2 times 1, that doesn't seem as big as 3 to the 6th power, does it? 3 times 3 times 3 times 3.
But when you go really.
But when you get real big, what happens? So what's your intuition here? Exponential versus factorial? Yeah, good guys. That's right. Very smart. Oh, you guys are so good. I can't trick you. Yeah, but the nice thing about this ratio test, you don't have to do this first. You just do the you do the term divided by the previous term, and it's just going to tell you. You don't have to think of another series, right? So let's just go and see what happens. So let rho equal the limit as n goes to infinity of 3 to the n plus 1 over n plus 1 factorial times the reciprocal of my general term. Yeah, Joe was like, oh, had a face like, oh, I don't like that. I know. What? So keep in mind what just happened. So 6 factorial, guys, ready? 6 times 5 times 4 times 3 times 2.
N plus 1 times that factorial.
So 6 plus 1 factorial, right?
Oh, so it's going to be.
So what we're doing, if we do 7 factorial, 7 times 6 times 5 times 4 times 3 times 2 times 1, I'm going to say that is 6 factorial times what I added.
I like.
Yeah,
the way
so
that works.
we're gonna change this around. This is a trick that you just have to know, and then you're gonna get rid of that n factorial, and it's all gonna be good. So
Limit.
Amir told us this trick of doing 3n.
Limit
Thank you.
Oh.
So,
Nerd
you
point.
get a fireball. I
That's
know, I
It's a
know.
nerd point at this point.
You have to trade it. You're fire and you get a nerd point. Oh, I know.
I love fireball.
Eat it.
Oh, you get a fireball and a nerd point.
Well, she did twice in one day. She caught me doing something wrong. Thank you. Am I right now? 90 limit. Limit is in. Thank you so much. Such good mathematicians. You guys make me proud. So I'm going to convert this to n factorial times n plus 1. Right? Remember what I did over here? The n plus 1 times n factorial. Got it? N factorial over 3 to the n power. Bam, 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 bam. Love that. I love canceling. That's why I love the ratio test, because everything just, all those nasty pieces cancel. And I'm running out of room. The limit as n goes to infinity of 3 over, right? Convergence. 0 is okay.
Our negative numbers.
You'll never get a negative because for this to use this test, all the terms have to be positive. Thanks for asking. 0's good. Converges. Just like you guys thought. Okay? So that is it. I'm stopping. Oh no, I went 16.